The Atlantic Ocean in the background. Oh, there's the water tower right there. There's the water tower. 300,000 gallons of water in the tower. Another 100,000 in the piping. Do you wonder where the flames go? We have a place for them to pass through the mobile launch platform. This is a flame chute under each booster and the 3 main engines. If we don't have any place for it to go, it's going to the surface and it's coming back up. What did you just do? Cause your own explosion. Can't let that happen. That would be a bad thing. We're going to drop that 400,000 gallons of water over the platform with the thanks of these rain birds. These are 2 of the 6. And into the flame trench, which is 42 feet deep. That means we have a flame deflector that's 42 feet high. You've got to deflect the flames. If you've been out to the garden, there's little spikes under some of those rockets. Those would be giving flame deflectors. We've got 12 inches. We've grown along with the size and the power of the vehicles. And if you don't do this, if you don't use this water, this thing is going to shake to pieces. You crack windows in people's houses 20 miles away. It's 6,000 to 8,000 degrees on the pad. It's hot. Water evaporates very quickly. We're in the white room. This is where you board. Now, you cannot go inside that entranceway unless you put on a very special suit. We're working in an operating room, kind of. It's called the bunny suit here, so if you're out here in your regular clothes, that's okay. The hatch has a special cover on it. Somebody's taking pictures too. Somebody from NASA taking people up there. You have to be badged to go to the pad, and you have to have somebody who has clearance to get up there. But you must keep the hatch covered, because if you don't, with people and equipment going in and out of here, it will get damaged. This big hose here also pumps air in there. And the only way to get in is crawling on your knees. Let's see if they move this camera back. No. We're looking down from the vehicle assembly building over to operational support building 2. That's what we want to see, just a building. Usually it looks out at the pad. Today it hasn't been looking at the pad. It's one of the cameras that does replays for launch. It looks really cool. It's only 3.4 miles or 5.5 kilometers away from there. This camera view is a nice picture of Discovery. Here we brought the cargo to the pad. This is called the payload canister. Move the cargo into the clean room called the payload changeout room. These red hoses pump air into it, keeping it in a clean room atmosphere. Now when the canister is finished, it just comes back down, stands on there vertically, and then it goes back to its original location and lay it back down horizontal. This is where the nose of Discovery is. This is where the tail of Discovery would be located. There's the white room leading right to the door. This picture is on the main page right now. You can turn that into a screensaver if you wanted to. Our crew patches are all designed by the astronauts, even since the beginning of 1961 with Alan Shepard. April 5th, 6:21 a.m. became a little more official Friday with the flight readiness review. All the managers talk about all the big issues, and they said everything's rolling, we're doing it. As long as weather cooperates, we'll get off the pad. 50-50 chance. It doesn't matter whether the weather says 20% or 90%. It's a 50-50 chance that the weather cooperates and no last minute issues. This is our crew, Alan Poindexter, commander, his pilot, Jim Dutton. This is our mission specialist, Rick Mastracchio, Stephanie Wilson, Dorothy Medcat Lindenberger, Naoko Yamazaki, and Clay Anderson. Rick and Clay have 3 spacewalks. They're going to replace an ammonia tank assembly. They're going to replace one of the gyros on the truss. They're going to bring in a Japanese experiment. They're going to need the Canada arm to attach Leonardo, which is a cargo carrier. We're bringing out new experiment racks, food, clothing, all sorts of different things to the space station. Leonardo comes home with dirty clothes, trash, equipment no longer needed. They plan to make that permanent. When it comes home, it'll have different shields placed on it that'll be more impact-proof to stay in space for a longer period of time. This is Bob Mankin. He was one of the spacewalkers of STS-130 crew of Endeavour, and this is one of their components they just brought to space. That is the Earth in the background. This is Cupola. It's a 360-degree observation area. You can run the Canadarm and the robotics from there too. It was attached to node number 3. Right here, this is node 3. These two pieces make us 98% complete now. You needed the help of the Canadarm right here to make that move. This is the Japanese lab, see? Japanese flag in the background. This is node 1 that we're attached to. We're on its left side, or what you call the port side. Oh yeah, that's Endeavour in the background too. Got to close the covers over the cupola before they left, so the residual of the maneuvering fuels wouldn't have caused any damage. This is the European lab, Columbus. This is node 2, which is Harmony. This is our docking port right here. This is pressurized mating adapter 2. That's where the orbiter will always park in space. This is the Japanese lab, which is called Kibo, means hope, Japanese. This funny object is the Japanese Experiment Exposed Facility. American lab, Destiny. Robotic hand, Dextra. Node 1 is Unity. And this is our airlock. This is Quest. This is where you leave for your spacewalks. This is node number 3. It's been named Tranquility. This cupola originally arrived on the side. We just used the Canadarm to move it to here so it could face the Earth. This is pressurized mating adapter 3. It was here on node 2. We did not deliver it. Came by another mission. And we moved the Canadarm, moved it from here, and parked it on node 3. Why? It's pressurized mating adapter 3. So that's where it belongs. It's another docking port. Pressurized mating adapter 1 is different because we're attaching to Russian components. Russian Soyuz vehicle and Zarya. Zarya was the first piece put in space in November '98. Then we brought this pressurized mating adapter in node number 1, Unity, and that started the space station in November, December '98. These are cooling systems right here. 2 of the 8 solar arrays that provide power. Fly around the space station 600, 625 feet away. That's how you get the full view of the space station. This is Russian Progress ship, brings up supplies to you. This is Vezda, a Russian component. We're 356 feet in length, thanks to Discovery. Brought up the last set of solar arrays last year in March, and made it bigger than the football field for sure. Okay, I know you see the curvature of the Earth, but do you notice the blue line around the Earth? That's the ozone layer right there. Keeps you protected from the sun. Still need to wear sunscreen. Use the NASA website, nasa.gov. Use spaceweather.com. Find out when it passes over your area. It can tell a day, trace the scene, direction approaches. It's a big bright star. It's about 5 miles a second. It's pretty quick. This is the crew manning the space station, Expedition 23. Oleg Kotov, he is commander. TJ Kramer, Suichi Noguchi, those are flight engineers. They'll be coming home about May to June. We have people leaving on Friday,